Very nice meeting you all. We're Timbr.ai, and we help companies transform data into knowledge. Last year, we were also awarded by Gartner as a cool vendor in data management, specifically targeting data fabrics and data mesh architectures. So when we say moving from data to knowledge, what does that mean? In high level, most of the data today is stored in relational databases, and working with them, you need to have this entity relation model between the tables and the different views. It might be spread across different data sources, and a lot of technical complexity is encapsulated by working with the relational models. Now, what we help companies do is work with the data closer to how we humans perceive the data. So we think in terms of business entities, their hierarchies, properties, and different relationships between those business entities. We don't think about where do I have data of this business entity stored and how do I connect it to a different schema or a different table because it relates to a different business entity and I want to get information about both of them. So we help bridge that gap and really facilitate and democratize the data for the organization using business terms, regardless to the data structure complexity. So basically, Timbr is a semantic graph data management platform that transforms any data source into a knowledge graph. So you can, in the platform, you can create as many knowledge graphs as you want. All of them are virtual. So they seem like a virtual semantic layer, but the model is actually an ontology. So that's a graph. In each model, you can first of all connect as many data sources as you want. So yes, Timbr is also a virtualization engine, and I'll touch that point in a few slides. But in the model itself, you build your model with business entities, their hierarchies and relationships. You can encode business rules directly in the data model and unify naming conventions, both on a metadata level, but also on the data values themselves. So this is also very relevant for international enterprises or organizations, where sometimes you have different languages for the same products or the same people or the same processes. But just due to the different languages, the data won't be as similar as we'd expect. Of course, we've built Timbr as a virtual solution based on standard SQL. So there's seamless integration with the entire ecosystem of the organization. If we're talking about BI tools, data science notebooks, web applications, and I'll show a small diagram of the solution ecosystem in the next slide. And Timbr is really made for big data. So connect your data lake, your data warehouse, or any big data engine to support and accelerate the analytics. And most importantly, so this is a very big differentiator between us and different graph solutions, that there's no data copy required. So we don't store any data, we don't copy the data. And I'm guessing the demo, everything will be much clearer. So let me move on and show you an example of the difference. So on the left side, we can see a database schema view. This is actually taken from Google BigQuery data warehouse, where when I look at my database, I get a list of schemas. For each schema, I get the list of tables. And for each table, as you can see, we get the list of columns. But if I'm a data consumer and I'm interested in information about customers, now I need to go one by one, allocate where that data resides. If it's spread across different tables and schemas, then I need, after I allocate the data, I need to understand how am I going to connect that data together, and only then I can extract the information. This process can be very long, not so intuitive, especially with large or big corporations, and it's very time consuming as well. So leveraging the work that someone else has done in the past is not necessarily accessible for me to leverage and just use right away. Where when we look on the right side on Timbr ontological view, we can immediately understand what are the business entities we have data on when we look at the model. So we have here a concept of product and different classifications of product. We have campaign, we have brands, we have customer. And me as a data consumer, I don't care if the data about the customers is coming from multiple tables in multiple databases or from one. I'm just interested to get all that data that I need for my use case. So first of all, you get a much better business-oriented representation of your data. Besides that, we hide all that complexity of understanding how to connect the different tables, what are the business rules to single out a specific segment of a customer. So, for example, here we can see 4 different classifications of a customer. So we have VIP customer, we have churn customer, we have recurring customer, and the new customer. And for each of them, we have a different business logic that applies to. So, for example, let's say in Timbr, a new customer is every customer that made a purchase in the last 30 days. Me as a user, I don't need to remember that rule. Obviously, this is a very simple rule, just for the sake of the example. But me as a data consumer, I don't need to remember that rule or what I need to filter or what are the organizational classification of a new customer. It's already embedded directly in the model, and anytime I will query the new customer concept, it will already be included. Any questions here? No. Okay, great. So moving forward, and I guess I will finish with this one, and then we'll move over to the demo to see the platform live. So what we can see here is the actual ecosystem of Timbr, of our platform. So as I mentioned, we see ourselves as a middleware between all the data sources and the consumption side. So you can see here on the left side different data sources that can connect to Timbr either via ODBC, JDBC, or natively. We're talking about Snowflake, Delta Lake, Databricks, of course, BigQuery, SAP HANA, MongoDB. You can also query and map CSV files, Parquet files, and of course, NoSQL data sources like MongoDB, Elasticsearch. All of them connect to Timbr. In Timbr, you create your semantic model, which really facilitates the data discovery, but you can also use Timbr as a data discovery tool once connected to the sources to just query and see and validate all the information you have in your raw tables. So through Timbr, you can either choose to query the graph, the semantic model, or you can actually query the physical tables in the databases themselves. Besides that, Timbr facilitates data harmonization across different sources or different outputs. And as I mentioned, Timbr comes with a visualization and a virtualization engine. And just like any other virtualization engine, we're dependent on the least performant data source. And that's why we've also developed an intelligent cache engine. And I can dive into that if you want. And besides that, yes.
So I'm more interested in learning how you run caching. I think that's where the major problem lies. So yeah, if you can elaborate a little bit, maybe during the demo or in this slide, I'm okay.
Sure. We have a dedicated slide for that. I wasn't planning to showing, but I'll show right after this slide, and we can dive into that if you want. Okay, so and besides the virtualization engine, the cache engine, of course, the semantic model leveraging knowledge graph capabilities allows you to really enjoy the inference between the different hierarchies from different concepts and the relationships, which there are no real way to express relationships in our current relational data structures. When we talk about consumption, so first of all, the output from Timbr can be through simplified SQL, which you will see in the demo, different OLAP aggregations, denormalized views, graph analytics, or graph exploration. Lately, we also added a new capability we call BLI, which is a business language interface, where you can actually query the knowledge graph using kind of a free text, but based on the knowledge graph semantic terms that you've defined. And everything can be consumed through either JDBC, ODBC, or REST APIs. And we have here a few of the examples that you can query the graph through. So actually, the business users don't really need to know that you're working with Timbr, because they will only get enrichment from their data and much more capabilities with their data but they can still use their softwares, the same BI tools, notebooks, or if you have an internal data platform and you want to connect through API with Timbr, obviously that's all available. So you can query the graph in Python, Java, Scala, R, etc. Any questions here about the ecosystem or integration connectivity?
Yeah, one more question, right? So if you can elaborate a little bit technology behind Timbr as well, just to understand, right? So to give you a little bit context, right? I'm trying to relate this with Starburst and understand, right? Apart from graph database, what we are creating as a part of Timbr, what else is different from Starburst?
So I'll answer what is our approach. So first, what we see is that when you're talking about scale, the more data you have, the more you scale the solution to more users and to more data sources. Data virtualization fails at performance. Doesn't matter if it's the Nodo, Dremio, Starburst. Data virtualization in general fails the more data sources you have because you need to ad hoc at runtime do all the joins. Now, this is exactly why we introduced the materialization engine in Timbr, and I will also focus what we in Timbr focus when we come to a large customer and how we tell him the approach should be. You start by building a virtual layer. Now, the thing that distinguishes us from other tools is that Timbr is a modeling platform. You actually model and apply business terms. So it's not a logical data model. You're not limited to tables and columns. You can actually create business entities. You can classify your data. You can add relationships. So Timbr is fully equivalent to building a graph data model on top of your relational databases. So the integration part becomes much more faster and intuitive. That's one aspect. Now, if the company already adopted a data lake engine like Dremio or a virtualization engine, they can simply connect to Timbr, and Timbr will be the consumption zone, right? Because it will have all the business terms, all the relationships. I will show you the value. Even if you use a different virtualization tool, I'll show you the value in the demo. Why should they adopt Timbr as well? Why building a logical data model is not enough for a data mesh or a data fabric if you want to build an enterprise level model. Now, the second thing that we invested in Timbr is that our virtualization engine is based on Apache Spark. So we decided to go hand in hand with Databricks. So most of our customers use Databricks, so they can actually use Databricks clusters as the execution engine. And this gives them the same flexibility, very much like you have in Snowflake, where different users on the same data model can run different clusters based on their workloads and needs, compute needs. And they're not limited by a single execution engine that runs on Timbr. They can still use the Timbr virtualization, which runs on Kubernetes, but they can, in a single configuration, say, I want the virtualization to be on Databricks. The second thing that we did with Databricks, as you see in this cache engine in this slide, the third option to cache is in the data lake. So if you want to cache data in Timbr and you have terabytes of data, you can still move all your data to an object store. This means that you can start virtually. If you face any performance challenges, you start caching. You can cache a business entity, you can cache a relationship, an all-up cube. You can create also aggregations in Timbr and cache only the daily, weekly, yearly metrics. And you can also decide where you're going to cache the data. So if we talk about data lake, then you're essentially moving to a lake house architecture using Timbr. You start materializing when you have performance issues. This should be the line of deciding when should I copy the data or not. If I face any performance issues, let's materialize in the data lake. If I need faster performance, Timbr offers 2 additional tiers because data lake performance sometimes is not enough for a real-time dashboard on Power BI or for web applications or some machine learning algorithms. You need near real-time response times. So you can also cache in Timbr in SSD. SSD give you data locality much faster than data lake, 10 times faster. But it costs you more because you pay per a gigabyte on the SSD, which is more expensive than the data lake. The next tier would be in memory. So in memory gives you real-time performance, 10 to 100 times faster than the standard data lake performance. And you can move between those tiers and manage costs, because you don't want to copy all the data. You don't want to cache all the data into in-memory, like a lot of solutions do. Here you can manage and you can move. Also, if next month the company's workloads change, you can promote another entity to the memory and move one back to the data lake. So the whole thing about Timbr is about creating a single consumption business model. It can be a data fabric or a data mesh. It really depends on if you want to build a single enterprise ontology that integrates all the data, or data products. Each ontology serves as a specific domain to solve a specific data problem, and they can manage performance associated with this. If you don't use Databricks or the Timbr virtualization, you can still leverage the Nodo and other tools if they already adapted. You know, we come to a company that already invested time, efforts, and they don't want to replace. So we can, in those cases, we can extend it with additional capabilities that I will show in the demo, or we can provide the full solution. You don't need to put together multiple solutions to get to bring what Timbr brings you.
So one last comment regarding the cache engine is just that, as Amit mentioned, you can promote or demote the cache between the different tiers according to different workloads. And all of the caching, obviously, the cache engine comes with the automation capabilities, so you can automatically schedule a cache according to a specific hour, day, week, month, etc. Or you can also do it by partitioning, so by a specific date, year, month, or by a specific column. And therefore, you don't really need to cache all the data all the time. You can do it incrementally. And let me just.
Is that a management strategy or based on request? Because you're a common semantic layer, right? Based on the request, can you sort of do the paging type of thing?
So that's not something out of the box in Timbr, but it's definitely something that you can programmatically set, you know, like rules to validate that if there's a specific entity or mapping or relationship that is being queried a lot, and you set the amount of what a lot means in the company, then to automatically run the SQL query to just move the caching between one tier to another. I hope that
we provide recommendation. So we have a performance dashboard. We don't automatically do this because it has costs associated with this. So a person needs to, you know, agree that he's going to pay storage or SSD or memory for the cache. So we do have the recommendation capability, but we don't do it automatically currently because it involves costs.
And then I think I'm not sure if I heard correctly, right? So you said like I can say cache that whole OLAP cube, right? So
yes.
Yeah, so I think like say I'm building an executive dashboard, right? And then which actually giving a say revenue overview across LOB. And if I decide to just cache that, I can do that, right?
Right, and you can cache also multiple layers. So if you build an entity and you cache the entity and you have a view and aggregated all of you on top of that entity, so you can also cache the view and also the entity. So you don't limit you, and you can build multiple layers of cache. And we see this all the time when we're talking about terabytes of data, right? Sometimes you want to you cache the hourly as daily, and on top of the daily cache it monthly, yearly for different metrics, for different scenarios, and that gives you a lot of flexibility.
Okay, so this require in that case like a refresh of cache, right? So if data is continuously refreshing, more like a real time or near real time, so this then require a refresh of cache as well regularly, correct?
Yeah, you can do full or incremental if you have a partition column. And also you can automate it. You can externally automate it after your ETL. So if you write a partition to the data lake, you can also trigger a refresh only the new partition, cache only the new partition and the metrics that are associated with it. So
okay.
Let me share my screen. I prepared a couple of demos. Some of them are new capabilities. Some of them are just going over the platform, showing you how it works. So if you have any questions, feel free to interrupt me at any moment. So first of all, let me introduce you to the Timbr platform. I'm as an admin, I can see what every user is doing on the platform. If I don't have access, then I can only see my recent activity. I can see the list of knowledge graph, query history for each user. I have a complete view of what's happening in the platform, and I also have access to the Manage tab. So a Manage tab as an admin, I can manage all the knowledge graphs and all the data sources, and I can also have access management. I won't dive into the access management, but just so you know, we support fully role-based access management, row-level security, to the granularity of giving access to a specific view, to the whole model, to a specific data source. You can manage all permissions to any level of granularity you want. And this also gives you, from security side, a lot of ease of use in terms of management, because you can manage the consumptions, and you can manage permissions on top multiple databases in a single location. So I'll move just to the knowledge graph management tab. Here's the list of knowledge graphs we have. I'm going to show you this specific demo model. I'll click edit just to show you the list of data sources connected. So here we have BigQuery connected, Databricks, MySQL, Postgres, and currently we have the Timbr virtualization here connected as well. And of course, you can change the settings of the knowledge graph here. There's many different optimization settings. And if I want to model, then I can go here to the model tab, which we have 3 different options.
Amit, can you just to show all other data sources for the team, because there are folks who are from Snowflake and others, so it will be very helpful.
Sure. So any JDBC connector, you see here, you can also apply your own JDBC connector. There is some built-in connectors you have here, but you can also apply your own JDBC. From Athena, Vertica, Redshift, SAP HANA, Snowflake, Denodo, Databricks, Impala, Hive, of course, SQL Server, Synapse. You can connect to REST APIs, S3, Azure Blob Storage. This is just the connectors we have in this environment. We have much more connectors available. Usually when we deploy to a customer, we set a preset of connectors to that customer based on the versions of what he has. But in the JDBC, you can essentially do whatever you want. So let me move to the model itself, show you the model of this knowledge graph. I'll click on it here. And I'll show you the value in terms of a user that wants to explore the consumption zone. So very simple model for data from multiple data sources. And we model here customer data, marketing data. So if we look at what is marketing data from our perspective, you can be user click, user impression, or a user transaction. When a user buys something, he moves from being a user to being a customer. Now, if I go and I want to see the type of customers, then inside the Timbr platform, first I can click on customer. I can see the list of properties. I can see the description for each one of them. I can see the relationships. So I see that a customer has a relationship to a user transaction. Creating a concept can be as easy as just coming here, defining the entity. You can select properties from other. So there's a lot of reusability that I can say, oh, if I create a customer, I can use the customer ID, name, and group that already exists in the model. I can also import from my database. Now, when you create a new when you import from a database, you can actually import all of your relational model into Timbr and start from there. Or alternative, I can define what are the business terms I want for this entity, and then I map the data sources to this business model. Now, Timbr gives you a lot of capabilities from the data model. You can create multi-value. So this is something that is very hard to represent in a relational model. But in Timbr, you can easily create a property that has multiple values associated with it, and then map a table to it. So for a user, it will be just another property of a customer, like email address. A customer can have multiple email addresses, and I can define email address as a multi-value, and then map the table of email addresses to this property. I can also define relationships. So Timbr automatically recommends relationships based on the model, or I can define the relationship myself. I can do a one-to-many, many-to-many relationship, a recursive relationship, a transitive relationship. And Timbr takes care of all this semantics according to this relationship, very much like a GraphDB would. I can define the direct relationship name. So if we define a relationship to a user session, has session and of custom, session of custom. So I can also define the inverse relationship name. The third option I will show you here below is the classification. So by filtering customer first, I see that there's multiple levels of customers. Let's go here to the settings tab. I'll change the node coloring and let's do it by the inheritance level. So now each level has a different color and I can easily understand what type of customers I have in my data without writing a single query. For a user that doesn't have access to edit this model, the Ontology Explorer becomes a visual data catalog because he can search all the entities, he can search all the relationships, he can search specific properties, and Timbr will automatically find them for him. He can easily understand what does it mean to be a retail customer. So let's edit the retail customer and let's see what is the business logic. So the business logic of a retail customer is just customer group equals to retail. But as a user, I can add more and more classifications and rules in the UI, or if I prefer, I can also do it in SQL. Everything you do, all the modeling you do in Timbr is not limited to the UI. Timbr is a full SQL shop where I can create the whole model using SQL statements. So this is the SQL to create the retail customer concept. The same applies for mapping. So if I want to see the mappings for this knowledge graph, then I can click on mapped and unmapped concepts. And I see that all the ones in red, you can see also here in the index, doesn't have any mapping because they only classify customer. Customer has the mapping. So I can come here to customer, click on mappings, and I see that the data source is MySQL. I can also see the SQL query. I can also edit it if I want. So this is the SQL query that I mapped to customer. You can also visually map your data. You don't have to do it in SQL. This is one option. The other option would click here, map. As I said, you can map a table or multiple tables to a concept, to a relationship, or to a property. So let's click a concept. I can choose the data source. You can choose the schema. And I see that in this schema, we already mapped two tables. So those tables aren't mapped yet. Maybe we need to add them to the a knowledge graph. If I click on customer, then Timbr will automatically try to suggest all the options for me. So Timbr also helps in the automatization of mapping data. You can filter the data. So I don't want to map data where the customer name is null. So I don't want anyone to see null customers. So this can be a filter that I apply, and then I can save the mapping. You can also explore the relationships. So if I click here, show relationship, it will show me the relationship to user transaction. And I see also user transaction has a mapping. Let's go back to inheritance level. And it's very easy for me to understand what relationships I have in my data. So before I move to the query side, any questions on the ontology, on the data mapping, on the capabilities that we allow in the user interface?
Is there any data masking associated here with this?
So you can apply data masking on a view level. So if I give you permissions and I want to mask specific properties, currently it's only via views, but we do plan to add it at a row level. So you can apply masking to different columns at a row level or user level.
Thank you.
Sure.
A quick question here. Any like Google Analytics 360, GA360 ontology, like is it available ontologies like that, or we have to build even for all data from scratch?
No, you can. We have many different ontologies we can leverage. Google Analytics is one of them. FIBO, the financial industry ontology. So there we have multiple in this, and specifically in this environment. For example, Google Analytics, we already have a full knowledge graph of all the entities from Google Analytics. So that's a bit bigger ontology, but as you can see, we already model and you can reuse it. You can reuse it and on with other customers as well.
Okay, and also like if we have any custom like dimensions or custom variables in the Google GA360, that also can be incorporated into the.
Yeah, you just extend it. Yeah, you just extend the ontology with your own custom properties, and that would automatically appear to the user.
For what industries do you have this, Amit? For what all industries do you have the ontology?
So we support the W3C ontology standards, or any ontology in OWL format can be loaded into Timbr. We fully support Microsoft ADRM models. So there's a list of industry models there. You can also import from other tools like Erwin, Colibra. If there's a tool that you want to import the data model, we can definitely easily generate the model using Timbr SQL statements. So the only thing we need to do is consume the model you want to import into Timbr and just generate the SQL statements from that model. So we have many customers that automate the process from industry ADRM models, for example, Erwin or OWL ontologies. So let me move back to the model just to show you how we can query. So here we have data from multiple sources, like I showed you, MySQL, BigQuery, Databricks, and I want to start running queries on this. So first, inside Timbr, I can still query my data sources. I can still go to MySQL, and I can still see all the schemas in MySQL, in BigQuery, and query them like I would query my database. What Timbr adds on top of my data sources is virtual schemas. Those virtual schemas represent the whole ontology, the whole business model we just created. So here we have customer, we have of the type of customers, and if I'll click, I'll just get a virtual table representing a customer. This can be behind the scene. We can have 20 tables, 3 different databases. The user does not care; he just sees a unified view of customer in business terms. Now, if I want to leverage the relationship, so here, if I query Timbr.customer, I get all the properties. But what about the relationships we created previously? So Timbr also automatically generates a schema called dtimbr. Dtimbr contains all the relationships. So here we also have customer, and now we're able to see all the relationships. So we have a relationship to user transaction, and we can access all the properties from the transaction, like the material quantity, the state, the unit of measure, net value, product brand. So the user doesn't need to understand how to join them, and Timbr does this automatically for him. You can. So let's look at the query that calculates for each customer group how many transactions and what is the net value. So here I select customer group from the Timbr customer. I use the relationship. So the relationship is just a virtual column. Any BI tool can also query this and consume it. You will just see the raw view. The raw view gives you how other tools that connect to Timbr will see the metadata. So this is standard SQL. We represent those relationships, and this is also part of the patent technology that allows you to express those complex queries using simple SQL. So here, customer group, made transaction, we count the transaction, and we sum the net value. Let's run this query. Of course, this is it runs on a virtualization engine, so it might take a couple of seconds. I'll also show you the cache. So exactly when we want to create those kinds of metrics, this is where the cache can help. We got the response. You can always debug and see what Timbr generates. This is the query that a user would need to write in order to run the query himself. So here we have just one join. So we join the customer data with the transaction data, but Timbr automatically generates all the joins automatically for the user. So the user doesn't need to do it. So there's 2 things you can take from it. 1, you don't need to create views anymore with Timbr. You don't need to do any more joins or unions. So the next query is about user session. So a user session, if we looked at the model previously, so user session can be an impression, can be transaction, or a click. And each one of them comes from a different source. So if I want to group by all the user actions and how many users, now I need to push down a query to multiple sources and aggregate the number of actions, right? So here I can see it takes around, I think, between 20-30 seconds. And I will also show you the same query after it's cached, so we can compare the performance. We don't need to wait 20 seconds for this query. Now, Here we also were able to express this query in 3 lines of SQL. Let's do an explain query. We see that Timbr automatically created a union all between BigQuery tables and MySQL table. So automatically Timbr also removes all the need to create unions and joins from the user. So let's say I want to create this as a metric. So I can, in Timbr, you have the third option here in the modeling called views. So I already created a view or already cached it. I just want to show you. We have here the model, and we have the view that essentially has the same query that I just showed you. User action, number of actions, and we group by. So now that I created this view called user actions, now Timbr can work with the view schema. So vTimbr contains all the views and cubes. So you can also create cubes in vTimbr, and you can cache them. So now when I run vTimbr to user action, you see I got the response immediately, because now if I do an explain query, it goes to the cache. The cache currently this cache is on Azure Blob Storage, so it's really fast just because we store the metrics that we are interested in. But this shows you how easy it is to model, how easy it is to query. And we have much more examples just to show you how unique when you create this model, what value you can bring. So one additional value that you can extract from Timbr is the ability to explore the data intuitively. So let's say I don't want to use SQL, but I want to explore relationships. So here, let's choose, for example, the Google Analytics Knowledge Graph. So we mentioned it previously, so it's a good example to do investigations. And I want to see user session. So I want to see user session on my website. I can click and select all properties, and I can also filter. So if I want a specific user, group of users, specific date, I can apply a filter here visually. But in our case, let's just take a sample of 50 users. And now Timbr is able to visually explore all the data. So I can click on this user. I can see he came from organic search in this date. I can see the full visitor ID. And I can also see the relationships. So I can get the device information for this user. I can get the geography info, or I can do it for all the users. So let's go here to the node group. I select find data connections. Let's click on user device. Let's get all the device information and also the traffic source, where this user came from to my website. So now Timbr will automatically run the queries and build those groups in the data. So for device, I can come and I can group them by operating system. So now we have clusters of operating systems. By traffic source, we can group by, let's use the source. So now we have the source. And now I can go and drill down. Those users came from Google search. Those users came from direct, so they directly entered my website. And we can see here Linux users, iOS. Here we have Windows. Very easy to explore, understand how everything is connected visually, very much like a GraphDB, just on top of my existing databases. Now, some of the new capabilities included in Timbr. So I showed you the cache engine, I showed you the graph. We also added lineage. So if I want to see lineage of a given model, so I have a different example for the lineage. So here we also have a model, very simple demo, that has data from 3 different sources. So we have company, customer, sales data, and we have, in this example, MySQL, BigQuery, and Postgres. Now, if I want to see the lineage and understand if I have views, so we also created some views on top of it. Now in the new version that we now release in Timbr, you have knowledge lineage. Knowledge lineage allows a user to select the knowledge graph. And now he can search whether it's a table, a data source, a concept, a view. So if I select one view and I click go, you see all the lineage. So it comes from company concept, this is the mapping, this is the table, this is MySQL. If I add the other view, now I can see the other view comes from customer and sales concept. We see different mappings and we see different tables, one from Postgres, one from BigQuery, and you get a complete lineage of all your data virtualization capabilities.
And can I
This,
feed this lineage to my existing data cataloging tool, like Alation?
So can you connect Alation to Timbr? Yes.
No. I think, there are two questions. One is the connection. Second thing is, since you guys are already in PNG, right? Say, for example, if we need to, say, because this data set is very critical, because actually I think in the new, the large deal that we want, right? So we are going to take care of both media, point of sales, RTTC, and supply chain partially. Okay. In that case, what the question is twofold. One is, yes, can you connect with Alation, which you said yes. Probably if you can show us whether Alation or others how it is, right? Second thing is, can you exchange this lineage with the other tools? Like, say, if I have to expose this lineage to, say, some other cataloging tool or governance tool, is there any APIs that you have which exposes this lineage, like lineage information?
Yeah, so you can connect to Timbr like you connect to any database using JDBC or DBC interface. So this lineage is exposed part of the JDBC tables. You can also connect using REST APIs, but all of this can be consumed from other tools using standard interfaces. The same interfaces you would connect to your own database, essentially.
So what are the interfaces that we use to connect, like, say, BI or Python or API? You use the same thing to access the metadata as well. That's what you're saying.
JDBC is the standard one. So if any data catalog can connect to Timbr using JDBC and import all the metadata, and then you will see this as well.
Okay.
Yeah. So
And then what
time,
is this
really
SQL?
cool. Yeah, sorry. No. What are you doing?
And I was just asking the SQL lab. Okay. Anyway, yeah.
The SQL lab?
Yeah.
This is the SQL editor I just showed you.
Okay.
Yeah, you can also search queries and save queries, but I showed you only the query part. The last thing I want to show is the natural language interface. So in this example, I want to show you how a user without any knowledge of SQL, business users, can query the knowledge graph. So the knowledge graph has the benefits of having relationships and business terms. And here I just want to start investigating my data in natural language. So we call it business language interface because you have autocomplete based on the ontology. So let's say I want to find analytics company. I can also click and I want to see where city equals, let's go to New York. Yeah, New York like this. So this will give me all companies, analytic companies in New York. So let's run this query. I get the response. I have the list of companies. I can continue exploring that. I can explore that in the graph or in my BI tool. I can see the SQL. So just for this simple SQL in NLI, find analytic company, this is the query on top of Timbr, and this is the query we generated on top of the database. Now, if you want to continue doing some more companies, more queries, we can go and make some more complex. Find company acquired by hardware company. So now we get all the companies acquired by hardware. If you want to be specific, we can go back and say, okay, now I want analytics companies acquired by hardware company, and let's do this a bit more complicated. So this will show me two companies, analytics company that were acquired by a hardware company. I can still see the SQL. I can see that Timbr generated two joins just to answer this one question. Now I want to find the people that work in those companies, right? So I found the companies that were acquired. I can see the funding date of those companies, to see how many funding rounds, many different information, country code, Canada, US, and so on. But let's find the person. So now I can go and say find person that works at analytics company, right? And that analytics company acquired by hardware. So now I run this query. I added another level of sophistication because now I get a list of people, 21 people that works at those analytics companies that were acquired by hardware companies. So now the query becomes much more complex. 1, 2, 3, 4 joins just to answer one question in a couple of lines. And we can also say, and person So, and person has degree. So let's also filter by degree, MBA, run the query, and we get the specific person we're interested in. I didn't have to do a single line of SQL. It was all based on the semantic model created in Timbr. And you can see the complexity. Even doing it in SQL without Timbr is very complex.
Hey, one
Does this statistical functions, aggregations, and concepts like that as well in the when we give it as a text? Does it do the aggregation as well?
Yeah. So first of all, you can also create cubes, and the cubes will be available here in the search as well. So if I define any metrics, I can easily search them also in natural language.